Good day, everybody. Uh, First of all, we need to know about Galileo's concept. Galileo was the first one who talked about that if something is falling down near the Earth's surface, so it will have the same acceleration due to gravity. Any object, when it falls downward near the Earth, it has same acceleration due to gravity. He named that it is G. And this was happening because the force of gravity was applied on it, and that force was making it to move to fall down with the same acceleration. So whenever an object falls down, so we can say that if this object is falling down with the same acceleration because of the gravitational force, and he named that gravitational force as Fg. So what Galileo told us, that is the first thing we need to remember. So Galileo said that all the objects fall with same all objects fall with same acceleration, same acceleration. It is near the earth. I'm talking about near the earth. And he said that that same acceleration is G, the gravitational acceleration G. And it is because that earth is applying the same gravitational force. So due to, you can say, due to gravitational force. This was told by the Galileo, gravitational force. And he named this gravitational force as F, the force, and G for gravity. He named that it is the force of gravity. And mathematically, he said that this force of gravity, Fg, is equal to mass times gravitational acceleration g. Here we need to remember that this small g, that's gravitational acceleration, is 9.8 meter per square second, or you can also say there is another unit that is 9.8 newtons per kilogram, because this is the force on the object by the gravity near the earth. So that's why we can also say newton per kilogram. And we can also prove this one, how meter per square second is equal to newton per kilogram. As you can see, if you want me to show it, so you know that newton per kilogram, and 1 Newton is the force that is applied on 1 kilogram object for producing an acceleration of 1 meter per second square. So this kilogram is cancelled, so the answer will be meter per square second. So this is how we can say that meter per square second is equal to Newton per kg. Okay, now getting back to the point that Galileo told us that every object falls toward the earth with the same acceleration by the force of gravity, and this force of gravity is sometimes is also named as weight. Force of gravity, Fg, is also called the weight near the earth. So you can also say that force of gravity is the weight that Also, you remember the definition of the weight is the pull of the earth or force of gravity due to which every object falls toward the earth. So mathematically, you can say Fg is equal to W, that is equal to mg. So for the sake of understanding, let me try to solve a simple example. If there is an object which is 1 kilogram in the mass, so it is falling toward the earth. So we can just simply say that how much is its weight or how much is force of gravity. So if this is the object, this object is falling down, this is falling, and its mass is 1 kilogram. So how you will find the weight or the force of gravity of this object? So you can say the weight or force of gravity of this object near the earth will be equal to mass is 1 kilogram and gravity is 9.8 Newton per kilogram. So you can say force of gravity on 1 kilogram object near the earth will be 9.8 Newton. So this is weight near the earth. But on the similar sense, if I want the same weight on the moon or any other planet, so we need to know gravitational pull of the moon. So as we remember from the previous sessions that the force of gravity on the moon is 1/6 of the gravity on the earth. So we can just substitute the value. Gravity on the moon is 1/6 of gravity on the earth. So you can just simply say that the same object which is falling, 1 kilogram object that is falling near the moon surface. So the weight of that object on the near the moon surface will be mass 1 kilogram times the gravity on the moon is 9.8 divided by 6. So this may be 6 ones are 6. So 1.33866 are 36, then 2 and 26.3. So 1.63 Newton will be the weight of the same object on the moon. And you need to remember one thing, that mass does not change with the location, but weight changes, force of gravity changes because gravitational pull changes, or you can say because the gravitational acceleration also changes. So this is the first thing that we need to remember. What is the force of gravity? So in simple scenario, I would like to mention that force of gravity is actually the weight of the object. How to calculate? We just need to multiply mass with the gravity at that position. So this was the first thing. Yes, guys, now we just talk about weight and force of gravity. The second thing is the normal force. That is very interesting that we need to understand. Usually, you know that uh, as Galileo said that there is a force that keeps the object moving downward or it acts on the falling object. So if the same object is placed on the table, so force of gravity is always there. Like you can see there's a sculpture of the Abraham Lincoln. So force of gravity on this object is acting downward. So mathematically, if there was only one force when this statue was placed on the table, so it should move, because when there is only a single force, that force keep the object moving in the direction of the force. It means that we need to think there might be some other force. That's why this pen, when it is like this, it has only force of gravity, it moves downward. So when it is on my hand, Why it is stationary? Because force of gravity is there, it is acting on it, but still there is another force that is balancing that force of gravity, and the net force becomes zero. That balanced force is named as the contact force. You know the contact force of the table. So that uh, contact force, when it is perpendicular to the surface, we name it the normal force. So here it is, in this case of the statue, normal force and the weight both are balanced. That's why it is not moving, but it is not always like that. So there are different situations. In those different situations, we feel the different categories. Let me talk about the situations of the normal force, and then I will discuss some examples. So first of all, what is the normal force? So normal force is actually the force, or you can say the contact force, which is perpendicular. The contact force perpendicular to the surface. So whatever the surface is, so this is always perpendicular to the surface. It may be equal, it may be more, it may be less than the weight according to the situation. So the contact force, which is perpendicular to the surface, is called normal force. So this is called normal force, and this normal force is usually represented by force with the subscript n Fn. Okay, now if in this situation that we can see here, I can redraw another situation. For example, this is the box, and this box is placed on the surface. So this is placed on the surface. So here in this case, there are two forces acting on the box. Number one is the force of gravity, or the weight of the object that is acting downward. Force of gravity is equal to weight, or you can say this is equal to mg. And there is another force that is acted on the box by the surface, is the normal force, and in this case this normal force is upward and totally opposite to the force of gravity. But if I use another situation, there is something on the wall. If you use that, this is the wall and this is wall. So here, if something is, or a box is attached with the wall by any mean, I am not considering how it is attached with the wall vertically. So where is the force of gravity? Force of gravity is always toward the ground, downward. But in this case, your normal force will be normal to the surface. So normal to the surface is this one. You can see in this case, normal force is perpendicular. You can see this is the angle 90 degree between. In the previous case, it was opposite. Now it is perpendicular. But if I show you the third situation, that there is an inclined plane, for example, this is the ground and there is a ramp on the ground that is making some angle, let's say theta. So if there is a box placed on this ramp, now in this situation, where is the normal? Okay, as I was saying, there is a third situation in which a box is placed on a ramp, like this is the box. So in this situation, as I told you, the force of gravity is the weight which is acting downward always toward the ground. So this is the direction of the force of gravity or the weight. But in this situation, where is the normal force? As I told you, normal force is the normal or perpendicular to the surface. So here in this situation, I can draw, this is the surface, so the normal force to the surface will be in this direction. So this is normal to the surface. Now, all of these situation you can see in the first situation, normal force is opposite to the force of gravity. In the situation of the vertically hanging box, normal force is perpendicular, and here normal force is not parallel to the weight, but it has a component of weight that is being balanced by the normal force. Usually that component is Fg cosine theta, that is balanced by the normal force. We will discuss in the later lessons. So this is the first thing that we need to remember about the normal force. Now coming to the point, if we are asked to calculate the normal force, for calculation of the normal force, we need to remind ourselves that whenever we are having more than one forces on the object, we usually use a concept of net force. What is net force? Net force is the sum of the forces. How to calculate the net force? If something is moving or forces are vertical, so we will add all the vertical forces, and if the forces are horizontal, we will add all the horizontal forces. So to understand this one, this example is very good. That says that your friend is giving you a special gift that you can say, and the mass of the gift that he is giving you is 10 kg, and it is a mixed mystery box with a mass 10 kg, and the box is resting on the table. So first thing uh, is asked to find the weight of the box, and also you are asked to find the normal force. So whenever it is resting on the table, you can say, as you know, there are two forces. One force is the force of gravity or the weight that is acting downward, so you can say force of gravity or the weight, and the other is the normal reaction. Because this is resting on the smooth surface, so normal reaction is upward. Now, first of all, I'm going to talk about the weight. So whenever we are going to find the weight, I told you earlier on that the weight is equal to force of gravity, and which is calculated by multiplying mass with the gravitational acceleration. As the mass of the box was 10 kg, so you will put m as 10, and gravitational acceleration near the surface of the earth is 9.8. So first thing we found, that weight of the box that is acting downward is 98 Newton, and it is downward, acting downward 98 Newton. Okay, this is the first thing that was asked, and we found it. Now on the other hand, they also ask us to find the normal force. So when we are going to find the normal force, I need you to remind that how many total forces are acting vertically. There are two vertical forces acting on the object. So we will use the concept of F net. So F net is about the vertical forces, so you can also say sigma. Sigma mean sum of all the forces which are vertical, sigma Fy. So now how many forces? So how many forces are acting? So F net is equal to sum of all forces. There are two forces, Fn, the normal force which is upward, plus the force of gravity which is equal to the weight. Now you need to choose that which force you are taking positive and which force you are taking, because usually we consider the upward as the positive. So F1, Fn we will consider the positive, and Fg we will consider negative. So here in this case, I will say Fn plus negative Fg. But there is another thing. According to Newton's second law, when there is no acceleration in the object in any direction, so no acceleration mean the net force will be zero. So net force will be zero. You know, Newton's second law said F is equal to ma. So F is zero means ma is zero. So here I will substitute F net because there is no acceleration. So I need to mention this word. This box is placed on the surface. It is at rest on the surface. So no acceleration. Whenever there is no acceleration, so please keep it in your mind, either no acceleration vertical or no acceleration horizontal, F net is zero. So here F net I put zero, and Fn that we are going to find, minus plus becomes minus, Fg we found is 98. So this 98 will move on the other direction. So this will become 98 is equal to Fn, or you can say Fn is equal to 98. So in this case, when the same box is resting on the smooth surface, it has only one force downward, that is the weight, and one force upward, that is the normal force, and these are balanced. So you can say Fn will be equal to the weight. So in this case we found the force is equal to the weight. Okay, now I will move to the second situation, that this box of your friend is now pulled by a force of 40 Newton. Sorry, no, pushed downward. So someone is applying a force, a pushing force on it. When it is someone is pushing it downward, so what kind of situation is created? Let me show you. When someone is pushing it down with some force, so the situation created is like this way, that I am going to show you. Okay, now, the second situation is that your friend is pushing the same box downwards with a force of 40 Newton. So the situation looks like this diagram, that the box is resting on the smooth surface, and suddenly it has a normal force, normal contact force, and your friend is pushing. So now what you have three forces. One is the force of gravity, that is Fg, and it is acting downward. The other is the normal force, which is upward, and the third one is another force downward that is applied by the your friend, and it is downward. Now in this situation, what do we have here? I told you all of these forces are downward. Now you are asked to calculate the normal force. So what we need to do, I will use the same equation again, and I will say that sum of all the forces that we usually use, sigma Fy, that all the vertical forces are F net. So sigma Fy or F net will be equal to sum of all the forces. So how many forces we have here? Fg, we have here Fp, we have here Fn. Now again, as I showed you in the previous example, that we consider upward as positive and downward as negative. So in this situation, there are two downward forces and one upward force. So downward force, the weight is, I will consider it negative, and downward force Fp, the force of the person, I consider it negative. So now what we have, as it is still not accelerating, no acceleration. So as I told you, F net is zero again because there is no acceleration. So F net is equal to minus force of gravity or weight minus plus minus force of the person acting downward plus the normal force, all are equal to 0 because it is non-accelerating box. So F net is 0. I substitute F net 0. So it will become 0 is equal to weight we just calculated little while ago was 98 Newton, and the person is applying a force of 40 Newton as well. So Fn in this situation will be 0 is equal to negative 138 plus Fn. I will move negative 138 toward the other direction. So this will become 138 Newton force of surface or Fn. So I found here Fn is equal to 138 Newton. Now I just want to remind you one more time, when there was no push of the person, Fn was equal to the weight, but now there is an extra force added, so we found that Fn is now greater than the weight. But in the previous case, in this situation, Fn is the greater than the weight, and in the previous case, here Fn was equal to the weight. So here both were 98. So you can say Fn, the normal force, is not always equal to the weight. It may be sometime equal to the weight, sometime it will be more, sometime it may be less. Okay, now we are going to the last part of the same example. Now your friend say that I want to pull it upward with 40 Newton force. When he's trying to pull it upward, what kind of change you can feel? So the diagram will change a little bit because your friend is now trying to pull it upward. So the diagram in this situation changes to this situation that he is pulling it upward now. Okay, in this scenario, when he is trying to pull the same mystery box with 40 Newton, but there is one thing that common in this situation also, that still after this force it is not moving. Why it is not moving upward? Because weight is 98 Newton and 40 Newton is less than 98, so it will not accelerate. So here I just mention one thing, there is no acceleration as well. So acceleration is 0, no acceleration in this situation. So now they are asking us to find the normal force in this situation. So again, I will start from the same concept. Whenever there are more than one forces, we use all of these forces are vertical. So I will say F net is equal to sum of all the forces. The forces are one force of the person that is upward, one is the normal force that is also upward, and the third one is the force of gravity, the weight, which is acting downward. So I will put downward as negative and upward as positive. As there is no acceleration, net force is 0. The person is applying a force of 40 Newton upward, and the normal force we need to calculate, and the force of gravity was 98 Newton. So now in this situation, we have Fn minus 98 plus 40 gave me negative 58, and it moves to the other direction. It will become Fn is equal to 58 Newton. So here I just want to conclude one thing, that the normal force is when there is only weight and normal force and it is balanced, so it may be equal to the weight. If a force is added downward with the weight, so normal force will increase to balance that one. Why? Because there is a 40 Newton force downward in the second case, so that weight and both of them were balanced by the normal force. Here 40 Newton is attached with the normal force, so weight is balanced. That's why normal force in this situation is less than the weight. So please. Okay guys, until now we found that when the normal force when there is no acceleration. But in this situation, when there is a box, the mystery box that your friend gifted you is accelerating, and how? Because the weight of the box, we calculated was 98 Newton. Now your friend or the person is pulling it upward with 100 Newton. So it's for sure that upward force is more than the downward force. So it will accelerate upward. Now the question says that how much is the value of the acceleration? So we are asked to calculate the acceleration. So now our question is to calculate the acceleration. For that purpose, I will just start with the same scenario that what do we have here in this situation. This is accelerating. So whenever something accelerating, please keep it in your mind. You have to remember that we will use F net. F is equal to ma from Newton's second law. So F net is not zero, but it is equal to mass times acceleration from Newton's second law. Okay, now getting back to the point. So as it is having two forces, one is force of gravity uh, downward, and one is force of the person that is making it move upward, but there is no normal force in this case because it's not on the surface. So you will say F net is equal to Fp, the force of the person, plus the force of gravity, but because gravity is downward, so I will make it negative as we were supposing. So now F net is equal to mass times acceleration. Fp is 100 Newton, and minus Fg was 98 Newton. So here M, the mass of the box, if you remember what was 10 kilogram, 10 times A is equal to 100 minus 98, 2 Newton. So I will divide both sides by 10. So 10 will be cancelled on the left side. So acceleration of this mystery box when someone is pulling it upward is 0.2 meter per square second, or you can also say Newton per kg. So this is the acceleration of the mystery box when it is moving upward. So now we found one thing here, that whenever the object is accelerating, we need F net is equal to ma from Newton's second law. Okay, guys, this is the last example that I want to discuss with you guys. There is a lady that is moving downwards with some acceleration of 0.2 g, that is 0.2 times 9.8, and she is having 65 kilogram of the mass, the actual mass, the rest mass, but now she is these accelerating downwards, so we need to measure the weight of that lady. For that purpose, we will start from the first thing, that as it is accelerating downwards, so that first thing is comes in our mind, that net force in this case will not be zero, but the net force will be equal to ma according to Newton's second law. And secondly, there are two forces acting on the lady. So we can say that F net is equal to uh, downward force is the force of gravity, Fg, and the upward force is the normal force. As it is accelerating downward, so I will consider the downward force is lesser as compared to the upward force. So it's better to mention here Fn minus Fg. So whenever something is accelerating upward, you will say upward minus downward. But when something is accelerating downward, so downward force minus upward force you will put. So here in this case, as it is accelerating downward, so it means force of gravity is more than the force of normal force. So I will put Fg minus Fn. Okay, now for this one, because I am going to find Fn, so what I will do, I will move Fn to this side, so and F net to this place, so it will Fn will become positive, and your weight of that lady Fg remains as it is and F net becomes negative. Now I just substitute the values. Fn is to find, we know that, and Fg is the weight mg, whereas F net is equal to ma. But before, please keep it in your mind here, this Fn in this situation is the uh, measured weight. This is measured weight on the scale, whereas Fg is the actual weight, measured weight by the scale placed in the elevator. So we can also say that this is apparent weight. This is apparent weight because it may be different than apparent weight may be different than the actual one. So actual one is Fg. Okay, now Mg minus Ma, but you said that A is here 0.2 times G. So when we substitute here, so the weight that is being measured by the elevator, moving elevator, by the scale inside the moving elevator will be Mg minus 0.2 mg, because m is same, g is a is 0.2 g, so 1 minus 0.2 gives you 0.8 times mg. So 0.8 times mg mean it will be the 80% 80% of the actual weight. So if her mass was 65, so at 80% mass may be around 52 kilogram. So you can say that her actual weight was almost 640 Newton. That is now changed to almost 510 Newton. So she is having a weight of 510 Newton. And if you calculate the mass, you know mass will be M is equal to F on Fn over G, the gravity. That will be approximately 52 kilograms. So what we found here is when this lady is moving downward in the elevator, her weight appears to be lesser than the actual weight. So this happens when it is going downward. But on the other hand, the part B says, what does the scale read when the elevator descends at the constant speed of 2 meter per second? Constant speed mean no acceleration again. So in this situation, it is like the first example when there is constant V, it means that no acceleration. So v is equal to 2 meter per square per second, sorry, and it is constant. When it is constant, it means that no acceleration. So no acceleration means F net will be 0. So the same situation, if you check this equation here, so what you will find, you will see that this equation says that you might have Fn is equal to Fg minus F net. So F net is 0. So Fn is equal to mg. Which does it mean? That the scale will measure the actual weight. So actual weight was 640. So a scale will give actual mass, and the actual mass was 65 kilograms. So it is like the situation that the lady is not moving, she is on the ground at rest. So it's the same situation. So that's why this scenario uh, comes to an end, that whenever no acceleration, so the weighing scale will give you the actual weight. When it is going downward, the weight decreases. When it is going upward, the weight may increase. So I hope you guys understand this lesson. Thank you so much, and bye bye for now.